Topic 3, Part A, B, and C. So here we are, Part A. Number 1, which theory is best supported by a Doppler shift of spectral lines towards the red end of the spectrum? The red shift shows that the universe is expanding, the wavelengths are getting longer. So if I look at color, increasing wavelengths go that way, decreasing goes this way. So if I'm looking visible light, the red end of the spectrum has an increasing wavelength, so objects are getting further away from each other. Number 2, according to the Big Bang Theory, the universe began as an explosion and is still expanding. This theory is supported by observations that the stellar spectra of distant galaxies show a shift towards the red end of the spectrum. Number 3, the following diagram shows the home galaxy of our sun and solar system and 4 other galaxies that are trillions of miles away. Which galaxy is most likely moving away from the sun at the greatest velocity? Well, that one is going to be the one that's furthest away because there's less attraction. So that one would be galaxy D. Number 4, the following diagram represents the Milky Way galaxy. Which letter best represents the location of the Earth's solar system? Well, we're out on one of the arms about 2/3 way out. So that one, we're going to go choice C. Number 5, a star of high surface temperature and low luminosity, relative absolute magnitude, is most likely, so that you're back to your reference table. I need a high temperature, low luminosity. I'm going to be a white dwarf. Number 6, why does a star with a high amount of matter tend to have a short life? That's because those that have a high luminosity, they burn rapidly. They burn a lot of energy. So with that one, they tend to die quicker. So it's going to be choice 2. It consumes its fuel rapidly. Number 7, what is the single most important factor controlling the evolution of a star? It's its mass. Because like I said, we're a medium star, so it's not like we become a supergiant. Number 8, which of the following pairs of characteristics is the most important in determining the type of planet's atmosphere? That would be the mass of the planet and its distance from the sun. Number 9, which planet has traveled around the sun more than once in your lifetime? So you're back to your reference table. If I look at Jupiter, its revolution is 11.9. So for you guys, probably once. All right, and if I keep looking, since none of you are like almost 30 years old or 84 years old, the only one that's gone more than once in your lifetime, Mars, which is 687 days, which is approximately 2 of our years. Number 10, as the distance from the sun increases, the diameter of the planets. So we know that closest is Mercury if I'm looking at diameter. So it's getting larger, it's about the same, gets smaller, much larger, smaller, much smaller, about the same. So it's going to both increase and decrease. In the scale of the solar system, if the Earth's diameter were 1 meter, the sun's diameter would be, so you're looking at Earth's diameter compared to the diameter of the sun, and you would find it to be 100 times, well, it would be 100 meters then, if you do the math. Number 12, the diagram below represents Earth. Which diagram best represents Mars, drawn to the same scale? So if you look at Earth versus Mars, Earth's diameter, Mars' is about half the size. So that would be option number 2. 13, if the planets were all the same side of the sun, which line best shows the correct spacing between the inner planets and their distances from the sun at a scale of 1 centimeter equals 0.2 AU. AU is an astronomical unit in the Earth's average distance from the sun. The sun and the planets are represented by points of identical sizes, but the distances between them are drawn to scale. So if you're looking at that one, distance-wise, you would have to come here, and you would find it to be Choice number 1. They're about the same amount apart, then all of a sudden there's a larger increase here between Earth and Mars. Number 14. A planet was viewed from Earth for several hours. The following diagrams represent appearance of the planet for 4 different times. The inference that can be made based on the diagrams is that the planet is, if you're watching the dot, it's moving. So that it's moving because it's rotating. Number 15. Period of time a planet takes to make 1 revolution around the sun is most dependent on what other characteristic of the planet, and that's distance of the sun. The further away, the longer its period of revolution. Number 16. Which diagram shows a planet with the least eccentric orbit? So if it's got a low eccentricity, it's closer to being a perfect circle. So that one would be choice number 1. Number 17. The following diagram shows a planet's orbit around the sun. At which location is the planet's orbital speed the greatest? Remember, the closer you are, the greater your gravitational attraction. The greater your gravitational attraction, the faster you go. So with that one, it's closest at A, so its speed is going to be fastest at A. The further the planet moves away from the sun, the less the gravitational attraction, the slower it goes. So if I look at this diagram, it's moving fastest at A, then it's going to start slowing down. It's slowest at C, and then we'll start speeding up until it's at A, where it's going the fastest. So that's going to help us with 18. The diagram below represents a planet revolving in an elliptical orbit around the star. As the planet makes 1 complete revolution around the star, starting at the position shown, the gravitational attraction between the sun and the planet will decrease, kind of like it did here, we talked about, and then it's going to increase again. So it's going to decrease from A to C, and then it's going to increase from C to A. So choice 1. 19. Planet A has a greater mean distance from the sun than planet B. On this basis of fact, which further comparison can be correctly made between the 2 planets? Well, since A is further away, it's going to have a greater period of revolution than B. Number 20. What is the difference between a galaxy and a constellation? Now, a galaxy is millions or billions of stars, whereas a constellation is just a group of stars that forms a pattern. So the amount of stars. Galaxies have a heck of a lot more than a constellation. Number 21. How is a planet different from a moon? All right, the planet orbits the sun, where the moon has to orbit the planets. Nearly discovered planet, you guys have to do a little reading on that one. And then number 22. Compared to the periods of revolution of Mercury and Venus, this newly discovered planet's period of revolution is. So if you're reading it, you're going to find out that its revolution is shorter than both Mercury and Venus's, because it talks about the average distance away being 3.5 million kilometers in the reading, which if you look at your reference table distance-wise is smaller than either Mercury or Venus. So it's going to be number 1. Number 23. The density of the discovered planet has been estimated to be, and the answer to that one is 0.3 grams per cubic centimeters. Because it's 20%, only 20% as dense as Jupiter. All right, so you look at the your density of Jupiter and calculate. So if I look at Jupiter, Jupiter's density is 1.3, and you're taking a third of that, so your closest answer is going to be 0.3. The planet was discovered when it passed through Earth and the star Ogle TR3. Which event in our solar system results from a similar type of alignment of the moon between the Earth and the sun? If the moon is between the Earth and the sun, it's a solar eclipse. Okay, the next one, you actually just have to plot this information. Question 26. Describe the relationship between the planet's average distance from the sun and the planet's average orbital speed. the closer it is, the planet is, the faster it moves. That one, you could look right here if you don't remember. So when it's closer, it's going faster. The further away, it goes slower. 27. The orbits of the asteroid listed in Table 2 are located between two adjacent planetary orbits. State the names of these two planets. If you look at your average distance here, you're back to your reference table. So remember, AU is 1 AU is the distance from our sun to our Earth. So I need to basically double it, plus, well, like 2.5 times as much. So that I want, again, distance-wise, you're in between Mars and Jupiter. Next one. Based on the distance from the sun, which of the two asteroids listed in Table 2 has the greatest average orbital speed? Well, that's the one that's closest to. The one that's closest to is going to be Vesta. The following diagram represents an elliptical orbit of a spacecraft around the sun. Calculate the eccentricity of the orbit using the following directions. So, first thing they want you to do is write the equation for eccentricity. Distance between the foci divided by the major axis. Next, you actually got to measure. So you need to measure them. And when I go to measure, I'm going from the center of the foci to the center of the other foci. And I come out to about 3.9 centimeters. And then I got to do my major axis. Remember, my major axis is going to run right through. So I need to get right through, and I'm looking to be about 7.9. Then I'm going to mathematically calculate my eccentricity. Remember, eccentricity, you round it to nearest thousand, so 3 place values out. So 3.9 divided by 7.9, I get 0.494. Notice my units cross each other out, so there's no units for eccentricity. Moving on to question, all right, so it says, base your answer to question 3031 on the calendar model shown below, the inferred history of the universe and then your knowledge of earth science. 12-month timeline begins with the Big Bang, January 1st, and continues to present day, which is represented by midnight, December 31st. Several inferred events and relative times of their occurrence have been placed into appropriate locations on the timeline. 30. State one piece of evidence used by scientists to support the theory that the Big Bang event occurred. Well, there's two of them. So you're looking at either the red shift or you're looking at cosmic background radiation. 31. How many millions of years of Earth's geological history elapsed between the event that occurred on September 10th, which was the formation of the Earth and our solar system, and the event that occurred on September 25th in this model? September 21st is the formation of the oldest microfossils. So remember I told you how everything ties together. So this one you got to go back to your reference table, page 8. So if I'm looking at when the Earth and solar system is 4.6 billion years or 4,600 million years, because this is done in millions, and then I'm looking for my first microfossil. My first microfossil is here. I'm going to read, remember, you're reading over. So if I get, let's see, 4.6 billion minus 3.3 billion is going to come out to 1.3 billion or 1,300 million years. Using the characteristic stars graph, in your science reference table, list the 5 stars below in order of decreasing relative luminosity, with the letter A being the brightest. So my most luminous are going to be towards the top. So my first one, the highest one I'm going to have is Betelgeuse. After Betelgeuse is going to be Polaris. Then after Polaris is going to be my Aldebaran. Then I'm looking Sirius, and then our sun. Question 33. Describe how the Big Bang Theory can explain the observed Doppler effect of most galaxies. All right, Doppler effect is as I get closer to you, my wavelength decreases. As I get further away from you, my wavelength increases. So with that one, the red shift, the red being a longer wavelength, so as the universe is expanding, it's shifted towards the red. All right, I am going to skip questions 34 through 41. You have to read and you have to base it on the other things. All right, I think the other ones are a little more important. Base your answer to question 42 and 43 on the graph below on the characteristic of star graph or science reference table. The graph below shows the inferred stages of the development of the sun, showing luminosity and surface temperature at various stages. 42. Describe the changes in luminosity of the sun that will occur from its main sequence stage to its final white dwarf. All right, so if I'm looking at it, it's going to become a giant. So my luminosity is going to increase. And then after that, eventually a white dwarf, so my luminosity will decrease. So increase, then decrease. 43. Which star shown on the characteristic of stars graph in the Earth Science Reference Table is currently at the sun's final predicted stage of development? So I'm looking for it to be down here. All right, so you're looking at temperature-wise, and I know I'm going to be a white dwarf, so I'm looking also luminosity-wise. So I go to my reference table. My answer is going to be protoson B. Protoson B. All right. Base your answer to question 44 and 45 on your knowledge of earth science and your newspaper article shown below, written by Paul Reisner and printed in the Times Union on October 9th, 1998. All right, I'm going to have you guys read that. Question 44. The Big Bang Theory is widely believed by astronomers to explain the beginning of the universe. Why does the light from distant galaxies support the Big Bang Theory? All right, so it's back to the whole red shift. Red being the longer wavelength. It's showing that the celestial objects are moving further away from us. 45. Compared to the age of the Earth and our solar system, the age of the Earth and our solar system, to the age of these distant galaxies of stars. All right, so our Earth and our solar system is younger than the distant galaxies. Base your answers to question 46 through 48 on the diagram below. The diagram shows the positions of Halley's Comet and asteroid 134340 at various times in their orbits. Specific orbital positions are shown for certain years. The more round one is going to be your asteroid, and the more oval one is Halley's Comet. And notice where our sun is. The eccentricity of the asteroid's orbit is 0.250. On the orbital diagram, mark the position of the second foci of the asteroid's orbit by placing an X on the major axis at the proper location. All right, so what you actually would need to do is you need a piece of scrap paper. With that one, I'm coming here, and I am going to mark the edge where my major axis begins, and I'm also going to mark where the sun is. So I need to be that's how far away from my one foci to my end of my major axis. So what I'm going to do is take that, I'm going to slide. So this point is now on the edge of my major axis, and then that line right here is going to be where my other foci point is going to be. So there's my X. No math involved. All you have to do is scrap paper. 47. Determine which was traveling faster, Halley's Comet or the asteroid between years 1903 and 1908. State one reason for your choice. I am going with Halley's Comet move faster. Couple things. First of all, it was closer to the sun, so it had a greater gravitational attraction, so it would move faster. Also, if you look at the distance covered in that time period, it's more for Halley's Comet than it is for my asteroid. All right. So, last question. 48. Explain why Halley's Comet is considered to be part of the solar system. The reason Halley's Comet is part of our solar system is because Halley's Comet actually orbits the sun. All right, I hope that helps. Goodbye.